So, good morning, everybody. Today, I will discuss about the circulatory system. So, circulatory system, it is a system in which a fluid is actually circulated. Why fluid is circulated? You see, the higher animals consist of many cells, and cell form the tissue, and tissue forms the organs. So different organs actually perform different functions. So to perform the functions by the organs, energy is needed, is not it? So energy, where from? Energy come from food. So food, after taking the food must be oxidized. Otherwise, this energy located in the food cannot actually take off by the animal. So food must be oxidized, and due to the presence of oxygen, is not it? When food is oxidized in the cellular level, food oxidized. When food is oxidized with the help of oxygen, energy is released, and this energy is utilized to perform different functions by the animal. So when food actually oxidized with the presence of oxygen, the carbon dioxide must be released. Carbon dioxide also must be released. This carbon dioxide is more harmful for the animal body actually. So this carbon dioxide must be expelled from the body. Other excretory materials also actually released due to the oxidation of food. These excretory materials also must be expelled from the body. So this oxygen actually, this oxygen actually take off from the outer environment, and this oxygen transported to the tissue or the cell, and inside the cell when food is oxidized with the help carbon dioxide also actually produced, and other excretory materials also produced. These must be expelled. So this intake of oxygen and expel of carbon dioxide or other impurities which are not essential for animal, this must be expelled through some liquid in case of human, or in case of higher animals this is called actually blood or circulating fluid. So circulation is most important actually for animal, not only insects but also other animal. Without circulation of blood, without circulation of circulating fluid, this animal cannot exist. It is most essential actually for animal. So there are actually, depending upon the types of circulation, there are two types of circulation. Open circulation and closed type of circulation. Circulation open and closed type. Open type and closed type. Open type circulation means the circulating fluid actually circulate within a actually system. This circulating fluid, this is say blood or hemolymph, is cannot expose in the actually coelomic space. But closed type, a part of the circulation is performed by a system and another part is open. That means here circulatory system means the circulation of circulating fluid is actually conveys some system. It is tubular system. This tubular system is actually open type. This is called closed type. This is called open type circulating system and closed type. Closed type means the system is closed, but here the system is open. In some or a phase or a part of circulation is actually flow in a limited tubular structure, another part is open, and here all the system is circulated inside a circulating fluid. So my discussion will be restricted in insect as we are a man of entomology. So you see, insects, in case of insects, circulation is actually open type circulation. Open type circulation. Open type circulation, that means a part of the circulation is actually conveyed in a definite tubular system, another part of the circulation is actually open. So it is open type of circulation in case of insects. Of course, except insects, in some molluscan also open type of circulation. So you see, insects are open type of circulation, and circulating fluid is hemolymph. In case of higher animals, circulating fluid is blood actually, but in case of insect it is called hemolymph. But there is a difference between blood and hemolymph. I will discuss later on difference between blood and hemolymph. So hemolymph, it is also circulating fluid in case of insects and other some arthropods also. So you see, this is the actually cross section of a insect's body. This is the cross section of the insect body. It is the insect body. So suppose this is insect, this is insect, this is cross section. In that sense, suppose especially in thoracic region. So dorsal wall of body wall is called actually targum. It is targum. The ventral wall is called actually sternum. Ventral wall is called sternum. And lateral wall, it is ventral wall, and lateral wall, it is called pleura. Pleura or pleuron. It is lateral wall, lateral side. That means it is dorsal, it is ventral, and it is lateral. Lateral wall is called pleura, it is targum, dorsal, and ventral is called sternum. So it is actually body cavity. This body cavity actually provided internally by gut or alimentary canal. So this body space or body cavity is divided into 3 sinuses by 2 diaphragm, dorsal diaphragm and ventral diaphragm. Dorsal diaphragm actually situated at the dorsal part of the body of the insects, and this dorsal diaphragm jointed the lateral side of the actually targum. It is dorsal diaphragm. And ventral diaphragm is situated at the ventral side of the body, and it is jointed the lateral side of the sternum. It is ventral diaphragm. So these 2 diaphragm actually divided into 3 sinuses. The whole body cavity is divided into 3 sinuses. 1, 2, 3. Generally, nervous system is situated in the ventral region of the body in insects. This is nervous system. Say ventral nerve cord. And dorsally blood vessels or dorsal vessels is situated. Dorsal vessels. So dorsal vessels is situated in between the dorsal body wall and dorsal diaphragm. It is called pericardial sinus. It is called pericardial sinus, pericardial sinus. It is pericardial sinus, and the sinus of the ventral side is called perineural sinus. Perineural sinus. And the space between the dorsal diaphragm and the ventral diaphragm, in which actually gut is situated, it is called perivisceral sinus. Perivisceral sinus. This is the cross section of a ideal insect in actually thoracic region. So you see, in insects actually the heart is, there is no any specific type or special structure of heart. Heart is actually, it is also a tubular structure actually. So you see, it is the dorsal part, it is the ventral part of the insects. So dorsal vessels is actually situated at the pericardial sinus, and these dorsal vessels run from the posterior region to the anterior region along the dorsal body wall. So you see, it is, say suppose, dorsal side, dorsal body wall, and it is, say suppose, ventral body wall, ventral body wall. It is the insect's body. It is, you see, it is the pericardial sinus. It is pericardial sinus. It is perineural sinus, and it is perivisceral sinus. So dorsal vessels run from the posterior most portion of the insect's body to the actually anterior part. But in the thoracic region, from the thoracic region, here it is thoracic region, these dorsal vessels actually run along with the alimentary canal. You see, it is alimentary canal, say suppose, it is alimentary canal, say suppose. Along the alimentary canal, it is alimentary canal, say suppose. But posterior part of the dorsal vessels is run along the dorsal body wall, but the anterior most portion is actually run along the alimentary canal. That means it is actually separated from the dorsal body wall. So this is the actually dorsal vessels. It is dorsal vessels. These dorsal vessels has two distinct regions. You see, the posterior most portion which run from the thoracic region, here it is thorax, say suppose, thorax, prothorax, mesothorax and metathorax. From metathoracic region, these dorsal vessels actually dilate to form a sac-like structure. These segments of the dorsal vessels is called actually heart. It is called heart. The another parts of the dorsal vessels which are tubular, only tubular structure, and it is small. It is called actually aorta. That means dorsal vessels have two distinct regions. One is heart, another is aorta. Heart, there is a difference between the region of heart and aorta. Heart, in the heart region, actually it is provided with some ostia, number one. Number two, it has some actually dilations and constrictions. The linear dilations are jointed with some constriction, actually, just like this, actually. Linear dilation, it is dilation, it is dilation, it is constriction, again dilation, against constriction, again dilation, against constriction, and it is dilation. So this part of the dorsal vessel, that is heart, is provided with some dilation and constriction, and this constriction and dilation is provided with some ostia. Ostia means pore, through which actually circulating fluid enter into the heart or pass from the interior side of the heart to the hemocoelic cavity. But in aortic region of the dorsal vessel, the excurrent and incurrent ostia, that is, it is not porous, it is just tubulous. This is the difference. And the dorsal vessels, that means in the heart region of the dorsal vessels, has some actually properties of constriction and relaxation, just like a systole and diastole in case of higher animal. So this is the heart, and another is aorta. You see, and next I would like to discuss about the heart of insects. It is not a true heart, actually. It is not a true heart, but due to some muscles, contraction and relaxation is actually possible. So it is called heart. And due to the contraction and relaxation of the muscles of the heart region, actually circulating fluid circulate. So this part of the dorsal vessel is called heart. Actually, heart extends from the hind region of the body to the thoracic region, and another part of the dorsal vessel is called aorta. It is heart. You see, this heart is divided in a series of dilation, just like this. It is a series of dilation and a constriction. It is constriction, it is dilation. It is dilation, it is constriction. Like this. This is the dilation. It is a tube. Actually, tube. Though it is a tube, but it has some actually distinct region. It is constriction region, it is dilation region. This constriction, the actually junction between the constriction part and dilation part provided with some ostia. Ostia means it is pore. There are two types of ostia, excurrent and incurrent ostia. Excurrent and incurrent ostia. Excurrent ostia means circulating fluid enter to the heart from the hemocoelic fluid or hemocoelic space. Incurrent ostia. And excurrent ostia means blood or circulating fluid is actually expelled from the heart to the outside. So incurrent ostia and the position of the incurrent and excurrent ostia also different. You see, say suppose it is dorsal body wall, it is lateral body wall, and it is, say suppose, ventral body wall, it is ventral body wall. So it is lateral body wall, it is dorsal, it is ventral, is not it? So suppose this is the segment of the actually, say suppose heart. It is dorsal side, it is ventral side, it is lateral side. The excurrent ostia arises from the dorsoventral side. excurrent ostia. But incurrent ostia arises from the lateral side. Suppose this is constriction, it is again dilation, it is again constriction. So this is from this part, ventrolateral position, excurrent ostia arises, and incurrent ostia is situated in between the constriction and dilation of the heart. The number of incurrent ostia is actually almost same in the same species. The number of incurrent ostia is different in different species of insects. Of course, excurrent ostia is not actually present in almost all insects. In some insects, the excurrent ostia also present. So, next is, it is reported that Thysanura and Orthoptera group, it is reported, excurrent ostia is reported in the Thysanura and Orthoptera group. They are generally without valve. Another difference is in between excurrent and incurrent ostia. The incurrent ostia is not provided with valve. That means there is a valve, atrioventricular or atrioarticular valve in case of higher animal. So there is a valve through which actually blood flow from the outer side to the inside of the heart, but backward flow is actually blocked due to the valve present in the incurrent ostia. But excurrent ostia is without valve. Excurrent ostia have no any valve. So next is lateral vessels. So next is lateral vessels. In some insects, the heart bears lateral vessels. In some insects, actually heart bears lateral vessels, and these lateral vessels actually arises from the excurrent ostia. Suppose this is the ventrolateral side, and this is suppose excurrent ostia. Excurrent ostia. These excurrent ostia actually jointed with some actually tubular structure. It is called lateral vessels. That means laterally it is extended. It is a tubular structure, and it is jointed with the excurrent ostia. It is extended lateral side of the body. In case of cockroach, there are six pairs of lateral vessels. Out of 6, actually 2 is thoracic region and 4 in abdominal region. The terminal end of the lateral vessels is generally blind. This terminal end is generally blind. But in some cases, this terminal end is actually modified into some diverticulum. The diverticulum. Generally it is blind, but in some cases it has some diverticulum, and this diverticulum actually extended to some segmental organ. Say suppose sarky or caudal style. Say sarky or caudal style. Have you heard the term sarky and caudal style? Sarky, you see, depending upon the presence and absence of sarky and caudal style, you have to identify the male and female cockroach. This is sarky and caudal styles are actually situated in the last abdominal segment. You see, last abdominal segment. This is sarky and it is caudal style. Sarky and caudal style. So this lateral diverticulum, of the lateral vessels is extended to the base of the sarky and caudal style also. So anyway, next is aortic part. Aortic part means anterior part of the lateral vessel, actually anterior part of the vessels. Anterior part mainly. So this is called aorta. So you see, in front of the heart, suppose this is heart, in front of the heart of the dorsal vessel is called actually aorta, and it is generally open, though the posterior portion of the vessel is actually closed, but it is actually open. It is this aorta. This aorta has, in some cases, has some diverticulum also, and it is extended into the dorsal side of the body actually. These are jointed with actually some ostia and these are extended to some actually segmental organ, just like those which are arises from the more anterior region. These are actually entered into the antenna or antennulae, and those which are actually arises from the thoracic region, these are entered into the thoracic part actually. And this portion of the actually vessel modified into a special sac-like structure. It is called pulsatile structure. These pulsatile structure are mainly responsible for circulation in some segments, especially wing, leg, antenna, and antennulae. You see, the heart actually start from the metathoracic segments, is not it? It is pro, meso, and metathoracic segment. From metathoracic segment, this region is called aorta. So, from this part or aortic part, this lateral actually canal arises from the dorsal side of the body, and this channel actually modified into a pulsatile organ. Pulsatile organs is nothing. Actually, this tubular structure actually modified into a two ampulla. Say suppose it is ampulla, and it is reservoir. That means wing. Say suppose this is insects. It is dorsal side. It is ventrolateral side. The pro, meso, and metathorax. Say suppose pro, meso, and say suppose metathorax. So pro, meso, and metathorax. Legs arises. Legs arises from each segments. Is not it? Legs. Three pairs, and two pairs wings. Wings also arises from the metathorax and mesothorax. Wing. So these are lateral structure. That means from pleural region, it is arises from the pleural region. So this structure, that wing, legs, are innervated with a pulsatile organ sexually. Due to the constriction and relaxation of the heart muscle, as well as the constriction and relaxation of ampullary muscles, when the diastole is start, that means relaxation is start in the heart muscles, the ampullary region is extended. As a result, more blood actually flow from the wing to the ampullary region via the reservoir blood flow. In diastole, that means when constriction is happen, the more blood actually flow from the ampullary region to the reservoir to finally wing, leg, or antenna. So anyway, now I am going to stop here. The remaining part of the circulatory system, that means the mechanism of circulation, we'll discuss later on.